a little bit of a game show format that we're calling Vendor Showdown. To my left, I have Team Thunder, captained by Stefan Gillick of Intel. Also Olivier David from Bull, Devrajan Subramanian from Compute, Alistair McKeeman from QLogic, Wolfgang Dreyer from Microsoft, and Aaron Dittmer from Penguin. And to my right, we have Team Lightning, captained by Frank Betka from HP, also Christian Tanisescu from SGI, Paul Weiss from Eucalyptus, Gilad Shaner from Mellanox, Fritz Ferstel from Univa, and Payman Boomstengel from Samsung. So thank you very much for joining us. Also, I'm delighted to introduce my judges. What we're going to do is these contestants will come forward in pairs. They'll answer questions that I'll put to them after brief introductions, and we've got a panel of judges that will get to award a point to Team Thunder or Team Lightning. We'll keep a running score, and we'll see who's given the better answers in the opinions of our judges. Our judges are Nicole Hemshoff, who's the editor of HPC in the Cloud, works with HPC Wire, a great partner of ours. Yoshio Tanaka from AIST in Japan, and Rolf Sperber with Alcatel-Lucent. So we'll have a press perspective, a research perspective, and an industry perspective on the answers that are coming from our panelists. The question that I have for Intel and HP, this conference, of course, is about high-performance computing and cloud. And as we've seen, there's different types of clouds, as you were discussing, and different types of HPC. The question is, where do you see an intersection today, and what is the potential for the future? Stefan, do you want to answer first or second? All right, you're up, Frank. Go.
I'm up? Okay. So the intersection of HPC and cloud today is that high-performance computing has always been something where you access big resources remotely for the absolute majority of the users, and they wanted it in the most convenient way. Cloud technology provides exactly that, but has been attempted a couple of times, not very successful, partly successful, so there is a big potential for the future for that reason.
Stefan.
Okay, so I want to take the user view here. I think the user will not ask for, okay, what's the intersection of technology, but rather, how can that technology really help me? So you can't say one or the other technology is winning here. What we need to look for is that we have actually a seamless kind of a model of access, right, to the end user who is going to use resources which are either based on clouds or either based on private hardware, so that the interface is actually the same, right? And the applications which are actually the interesting for the end users also can use this type of environment, right? Oh. Okay, I switched it off and I didn't switch it on. So can I repeat everything I've said, or did you understand me? So what I was saying is, what we need to look at is the end user, right? Because the benefit we want to see out of that is based on more end users having access to technology, and we want to select carefully the technology which we use as an underpin for that. We have heard about that, but still again, we want to have an interface which is working for the key set of applications.
Frank, anything you'd like to add?
I think I'm fine with that.
Excellent. Stefan?
Well, I think I went over time already, so.
Go to the judges. You want to step up and award your points to the better answers?
Okay. Well, okay. Right.
Rolf?
I give my point to Stefan, because I think he made the idea of convergence pretty clear to the listener. And he didn't divide between technologies. Oh, sorry. He didn't divide the technologies. He said what the user wants. And I think this is the way we should go in convergence, from the user's requirements to the technology. Okay, thank you very much.
Yoshio.
I also give a point to Stefan, because I like the answer from the user's point of view.
Nicole.
I also give my point to Stefan.
3-0.
And the same point about convergence, which is kind of ironic that he gets the point for convergence when you're a converged infrastructure. But I think neither of you really answered the question about what the potential for the future is. I think if you're talking about users, there would have been 1,000 answers maybe for that question. Maybe like a broader view of how clouds are opening up maybe access to smaller research.
Thank you, judges. Thank you, panelists. Okay, isn't this fun? Question for our system vendor panelists. HPC applies to cloud in two ways. Of course, there's HPC running HPC applications in cloud environments, and then there's the providing HPC systems that are appropriate for the cloud providers themselves. So what role does the system or cluster provider play here, and how should end users think of a system provider with respect to cloud? Christian, do you want to go first or second?
I can go first. Can I sit here? Respond from here? Right, that's fine.
If you like.
Okay, great. So, well, I changed. At HGI, we certainly, as a system vendor, we look at cloud as completing the solution, right? So we see customers that have their own business in as cloud providers, and we provide infrastructure. If, for example, Amazon, so it has been quoted a few times today or yesterday, we provide about half of the infrastructure for EC2 and for the S3. We also have Carbonite as a major storage cloud provider there, where we provide the infrastructure. On the user side, I think what's important is providing applications that customers are interested in, and we work closely with a lot of ISVs, so closed source applications as well as open source applications, our own that we acquired recently, OpenFOAM being one good example for CFD. Essentially, we augment the cloud offering with expertise and advice for the customers, in particular the newcomers in HPC, although they don't have enough bandwidth, right, in terms of budget as well as application expertise in segments like computational fluid dynamics, finite element analysis, computational biology, computational chemistry, material science, and computational analytics.
Excellent. Thank you. Olivia, the role of the system or cluster provider?
Okay, so at Bull, we obviously build our own clusters, and we offer these clusters to our customers. And when customers come to us, usually they don't tell us, I want to run my application in the cloud. What they tell us is, we have that many simulations to do for our next project. We want to run these crash applications, and we will need these CFD applications for this vehicle project or aerospace project or life science project. And we need more flexibility in using our resources. And this is the way the question is asked by the customer. So at Bull, we provide these clusters, and we use these clusters. And the role of being a service provider is to offer a capacity to a user to use external resources in order to have more flexibility in the usage of its applications. And I will insist that not in the traditional cloud model. What we offer is real HPC clusters usage. So it's not virtual machines. It has an high-speed InfiniBand interconnect, high-speed I/O disk, everything that is needed to really take advantage of the applications, make the best use of the time of the customer, and make the best use of the expensive user licenses that they are using.
Thank you. Christian, anything to add?
Maybe one last statement here that it's important when we talk about HPC in the cloud to consider the dependency of the underlying platform of the application computational characteristics. So to have in portfolio scale out as well as scale up, and different incarnations of the scale out cluster depending on the interconnect, InfiniBand or proprietary, is essential to serve the computational need of the application.
Olivier? Excellent. Judges, Yoshio, do you want to go first this time?
In my impression, the answers are very similar.
No ties.
No time. So then I will give score to David because I like the idea to HPC, InfiniBand or Mailnet, that special device is very important to achieve high performance. So I like his idea to tackle with such programs.
Nicole?
So those were both good, kind of similar answers. I liked your point on the application side, and I definitely liked your point on the hardware side. The only thing that neither of you really answered was maybe the point about having, since this is HPC Cloud, having performance and hardware performance at sort of the pinnacle of importance. But I'm going to give my points to Christian, I think, on this one.
Team Lightning's on the board.
Well, cloud and technology might be very complex and very complex, but the perception of the user should be very simple. And I think Olivier gave the answer more simply, and so he gets my score.
All right, thank you very much. Okay, panelists, as you might expect, I've teed up an interconnects question from Mellanox and QLogic. Cloud computing presents two problems for interconnects. The first is getting information into and out of the cloud, which for public clouds often implies internet. The second is communication between the components within the cloud resource that's running the applications. So my question is, where are the areas in which high-performance interconnects come into play for cloud computing? Gilad, do you want to go first or second?
I go second.
All right, Alistair, you're up.
The interconnect within cloud implementation, cloud deployments needs to be fully virtualized. Cloud for me is the notion of dynamic workloads, virtual machines moving between servers depending on load. In that environment, everything needs to be virtualized, including the adapters within the servers. But this is at 180 degrees to what's required within a high-performance compute cluster today.
Gilad.
Yeah, so the way that I look at it is that the common aspect between HPC and clouds is efficiencies, as I said before, and you want to get the maximum out of the system. Either from service, right? You want to be able to do fast VM migrations and image movement and things of that sort because you want to serve more users, and the users wants to get their applications done much faster. As well, from cost perspective, you need faster interconnect, mean more users for the cloud providers, and using one interconnect for all the data movement within a cloud means that you can use a single infrastructure for everything. So at the end of the day, it's efficiency. And if you look on that, a lot of HPC components are being used for private clouds, definitely. We saw the Microsoft announcement 2 weeks ago with the demonstrations talking about bringing InfiniBand and RDMA into Windows 8 for the cloud, for the continuous availability and Hyper-V. We see more user on that. There is also aspect of connecting to the clouds. And if I'm just running some game or whatever from my laptop, I have a wireless InfiniBand in my laptop. That's me. Typically, you don't get that connectivity, but there are cases when you really want high-speed connectivity to the cloud, and there are some cases like NES and something like and other folks that really provide high-speed connectivity to the user space, or to the user desktop.
Thank you, Alistair. Anything to add?
Yeah, just last one. In terms of connecting to the cloud, there remains the issue which is suggested there of how you move your data across. I think within HPC, and I think that covers the majority of the audience here, we're used to very large data sets. And I think that there's an open question on how that data set moves to where the execution is taking place.
Gilad, anything to add?
Yeah, quick two things. One is that what we see in the cloud also there is a movement to parallelism, and it's the same as HPC. So you see Hadoop, you see other items like that, and that's definitely require HPC interconnect if you want to do things effectively. And the last comment is that we know where you live, by the way, so you need to fix the points now.
Nothing like a little threat of the judges before we go there. Well.
Okay, since I'm afraid of you, you will get my score, but actually there's a real reason why I give you the score, because I think it's not in the first place virtualization that has to take place, but it's really the question why and how can we arrange a deterministic way of moving data from A to B. And this is the interconnect between clouds, the interconnect or the access to the HPC infrastructure. Okay, thank you very much.
Great. Yoshio.
Actually, I agree with both answers, but I give my score to Gilad. Yeah, because I think it's important to proceed a federation of cloud. So the connecting of the cloud is more important.
Nicole.
Okay, how do I get wireless in front of me on my laptop? Thank you. Yeah, but actually, I do give you my point. Both of these answers are really good, but I think your sort of overarching emphasis on efficiency, user needs, the kind of general cloud connection, and your focus on data movement was really good. I think this is a slight one, and again, I really like Infinity on my laptop, so yeah.
All right, thank you, panelists. Thank you, judges. Question for Intel and Samsung. Stefan, please stay seated with your foot, by the way. You don't have to get up. One argument in favor of public cloud models that we hear is this notion of economies of scale, as large providers offer time slices on vast computational environments. So what barriers and what technologies do these providers need to consider in order to achieve efficient, reliable performance at ultra-scale levels? Payman, do you want to go first or second?
I could go first.
All right, you're up.
Efficiency goes back to power consumption, performance per power. Reliability goes back to hardware. All these aspects means that the providers of the cloud needs to come back to their core capability to look at the hardware that they buy. They still get back that into their data centers and not rely on the providers. Green starts with a green component, and hardware play a great role here.
Quick answer, over to you, Stefan.
Yeah, so I think public clouds are a main mean to what we want to achieve here, which is sort of democratization of HPC. So what kind of technologies are important? I think I want to mention three. Security has been mentioned, and that goes down to hardware and software technologies which need to be supplied to make your cloud secure, right? We do that at Intel, but I don't want to mention exactly what in means of time. The other is reliability. You really want, if you move your workload around between several instances of clusters, private clouds and public clouds, that your results are consistent. Right? We at HPC, we know that that problem exists, right, with numerical algorithms. So this is very important, reliability. And coupled with that is portability, right? If you really want to be successful in using cloud as a resource, in enabling people to really make more out of their applications and be better and be more competitive, you need to have a portable application, right? You cannot go down in any kind of lock-in route or something like that. It needs to be portable. It needs to be moved around public, private clouds and clusters as well.
Payman, anything to add?
That's fine.
Standing on your previous answer. Stefan, you good?
Yes, I am.
Excellent. Over to the judges. Nicole.
Okay, that was kind of a complicated question throughout the minute. there's a lot of layers there. I think I'm going to give my answer to Stefan here. Due to the reliability and portability, democratization of computing, your very broad answer to kind of a broad question. But your focus on green computing, I think, is an important topic for cloud data centers, given we're talking economies of scale here. So kudos, but you can say something.
I have to give my point to the team lightning, because I could see the difference or what's necessary to go to the multi-scale levels from the answer by the Stefan.
Well, since I read most of the recent reports on power consumption of data centers, I give my point to Samsung.
Tie game, going to the last face-off question. Question for HP and for Penguin, the last of our face-off questions. On-demand computing in HPC dates back to before the advent of the term cloud. Now we're seeing these cloud bursting described as a new kind of model with the word cloud in it. With cloud bursting, how has the notion of on-demand in HPC evolved, and who will benefit from it? Aaron, do you want to go first or second?
I'll go first. All right. I mean, for me, the notion of first of all, the question is pretty broad, so the answer is probably going to be quite subjective. The notion of on-demand, for me, directly relates to making computational resources available. And for me, the beginning of that evolution of this concept started with job schedulers. I mean, it goes all the way back to systems like the Cray 1 that had a local job scheduler that matched supply and demand of resources. And then as clusters evolved, we started looking at distributed systems. Schedulers started to distribute workload, and again, it was the matching of demand and supply. And then with bandwidth increasing, the next step was the concept of the grid, where actually geographically disparate clusters could aggregate resources and again provide an on-demand type of environment. So that's how I see the evolution. And then cloud for me is just the logical next step in that evolution, where the resources are made available on demand as a service. The difference for me between, at a very high level, between grid and cloud is that grid always means that you have organizations aggregate resources, and the people that use the resources are from the organizations that aggregate, whereas at grid, resources are made available as a service in public grids to anybody. So I see that as a slight distinction.
Thanks. Frank, how has on-demand evolved?
So, take your microphone. The first point is, I think on-demand has changed with the arrival of grid computing. And the promise of grid, just mentioned, was to ease on-demand HPC. We talk about HPC here. Now, cloud will carry this forward, and the promise of cloud is really to provide an additional access to HPC immediately, on-demand, when you need it, you can get it, and you want to get it fast. So the question here, your question is, who will benefit from it? And that is, I think, the real innovation that cloud computing will provide. For on-demand HPC, the key groups that will benefit are researchers who are, at the moment, not using HPC. They're considered too complex. They don't want to go into the batch environments. And second, what I expect, and there's a huge potential, is the small and medium businesses. Because they don't have the resources and don't want to think about setting up complex batch environments. They want, if they really want it, they require something that's fast, that's accessible, that's easy to use, and delivers results within a very short time frame.
Anything to add, Aaron?
Actually, yeah, I just realized I spent too much time on the evolution, not too much on the time who's going to benefit from it. I totally agree with Frank.
I basically see the concept of HPC clouds as another step in the democratization of supercomputing. Right? I see the Beowulf clustering was moving to commodity systems that are interconnected was the first step, and now I think the barrier of entry to high-performance computing has been lowered again through the concept of cloud computing and HPC clouds.
Frank, anything to add?
Yeah, I just want to emphasize on-demand computing, the group that will also benefit from it, not talking just only about small and medium businesses, are all the researchers that today are not using HPC, right? Environments, scientific areas that are completely unaware of HPC, so it will definitely broaden HPC big time.
Excellent. Let's go to the judges. Ralph, do you want to start us off?
Well, I give my point to Aaron because of his historic overview. I think it's a good idea to say that grid computing or cloud computing is not really a new idea, but it derives from scheduling, it goes over to fast networks and things like that. And I think it's everybody who will actually benefit from it. So, to your point.
Joshua.
I will give my point to Fritz. I completely agree with you. It's my answer.
All right.
So I give you a point and I give you.
You can't do it.
Can't do that though. I think actually you saved yourself by saying I spent too much time on this, I don't know the answer. But I liked your kind of general history overview leading up to cloud being a natural evolution. So that's my answer.
Point for Penguin. All right, well, we're very close match. We're actually not done. We've got two panel questions remaining, which will offer some additional points. And what we'll do is the points are going up. The judges will have 3 points each to award. The first panel question will be for the inner halves of the two tables. So Intel, Bull, and Compute on this side, and Eucalyptus, SGI, and HP on this side. These will be pretty quick answers, ping-ponging back and forth. And I'll just keep calling on you each. So to what extent, the panel question number 1, to what extent will cloud computing models increase the total HPC market? And let's start over here. Go ahead, Frank.
Are you looking for a number, a percentage?
Not necessarily.
Yeah, I believe it will have a big impact, definitely. And it will make HPC a bit more transparent. You will be accessing an HPC system, but you will not be aware that it is an HPC system.
Stefan?
Yeah, we were talking about democratization of HPC or supercomputing. I think it will be a key means to do that, right? But from a different angle, because those users who will be able to use cloud services, they might not even think about using an HPC or a supercomputing service. They will just see it as a plain service to solve their problem. And that's the key thing about the democratization. Like, people have problems, they want it to be solved, and cloud infrastructures can be one key means to do that.
Christian?
Yeah, I will use a slightly different term here, instead of democratization of HPC, to look at the simulation and analysis applications for scientists and engineers, and as an intellectual amplifier to help them design better products or conduct better research projects. Right? So the HPC will grow in the width as well as in the depths. So width means attracting new users, new companies, and in the depths, because in the same company, like an automotive company or an aerospace company, where today is the ratio of engineers doing simulation to those doing design is about 1 to 100. So 1 from 100 engineers really do simulation. This will increase significantly. Some projections show a factor 10x. So it's a huge potential here, and cloud is one of the basic technologies to foster this.
Olivier.
Yes, so I will have an easy answer to that question. Cloud computing already increases the size of HPC market today, and we have already seen on Extreme Factory some customers who are using, not really using HPC today. They were doing some analysis and simulations on their workstations, and they didn't have the capacity of knowledge in order to set up a real HPC infrastructure. And with Extreme Factory being available to them, we were very happy to use a few hundred cores for doing the simulation. It took them several weeks to run on their So yes, these new customers, which are new to HPC, are coming today because of the cloud model.
Paul.
I'll take it from two aspects. One from the public cloud side. I think the public cloud side is giving people that never had access to these type of resources. They can go to Amazon, swipe a credit card, and go. Right? So you got researchers that don't have access or are waiting for access that can just swipe and go. I see the same thing in the enterprise where developers need access to compute resources. They swipe a credit card and go. I think also another thing is data warehousing has been pretty popular in business, but the analyzing of that data was kind of a common set of resources. I want these common jobs run for me, and I want to see the results, right? Speedometers and tachometers and different things. I think now with the advent of big business moving into the cloud, that these services are easier to get to, and if they're going to be easier to get to, a lot more people are going to be using it. So I think the HPC market is just going to continue to grow because of things like that. It's easy adoption.
Devraja.
Well, it's a big opportunity for engineers who are working in small companies or engineers who are working alone to be able to use a lot of computing power. All that is true, but still, I think that the amount by which the HPC market is going to increase is also going to be dictated a lot by the way ISPs are going to adopt into the cloud market. Are they going to let you use power on-demand licenses, etc.? If it's an open source code, of course you can scale up as much as you want on very good systems. But it doesn't matter what kind of infrastructure we provide, what kind of API we provide. If you're not allowed to legally run your code somewhere else, then it's of no use. So there are still some things which need to be worked out, but it's still a very big opportunity for engineers to expand.
Anyone on Team Lightning have any last minute thing to add? Team Lightning standing, Team Thunder? Give an Intersect 360 research view. If you interpret this question from the standpoint of an HPC application getting run because of cloud that wouldn't have been run in the absence of cloud, the overall effect on the market is actually quite small, under 2% in the near term. But my opinion isn't important. I have no points to award. We're going to go over to the judges. Yoshio. And you have 3 points to award here.
I just take top 3 answers, which I like.
Okay.
Fritz. Frank. Sorry.
F stands for Frank.
Paul and Subramanian. So I need to give my 2 points to Lightning and 1 point to Thunder.
Okay, well, I have that perfectly, partially because of your answer from SGI's point of view about, I like the idea of an intellectual amplifier and the needs of the simulation community. Of course, the keyword here was democratization of computing, and you guys hit that, but 2-1.
2-1 Lightning.
Okay, the same goes for me. One of the reasons why I give 2 points to Team Lightning is Mr. Weiss, who is to the right
Right, good point.
and also his ex-neighbor. The 1 point for Team Thunder goes to Stefan, because he gave a very good explanation of how the market is going to increase. Thank you very much.
Thank you, panelists. Thank you, judges.